Today, I'm pleased to be joined by Xavier D'Hubert, and we're going to be talking about the financing structures that already exist or could emerge to really help drive the industrial CO2 abatement work that is so very needed. So, Xavier, can I just ask you, give a little flavour of your background, and more than that, sort of what's brought you to this point where you're working in this space and kind of working on decarbonisation as well?
Yes, thank you very much, Alex. So I am an engineer and I've been working for many years in both the cement and mineral industries as well as the power industry. The past 20 years as an independent consultant, and also the past few years focusing more and more on CO2 capture, methanation, green hydrogen.
And specifically, I think we sort of talked about this before, but specifically, most of your work has been in the cement sector. What sort of projects have you been getting involved with?
Yes, so I've been working in the traditional process side of cement, pyroprocessing, air pollution control, process optimization, and by extension now into matters pertaining to the energy transition and decarbonation of those industries, cement, lime, and minerals.
Okay, and then today our focus is clearly on kind of looking at the way that we can finance what are expensive projects. These are not small pieces of kit or off balance sheet investments, are they? So maybe again, could you just give a bit of context for that? What is it that you hear from your clients when you start talking to them about these sort of larger scale projects? What are the concerns? And then let's also we'll then talk about the scale of investment that's needed.
Yes. So I will mostly take example from the cement industry, but it's clear that it would apply to the steel, glass, pulp and paper, and similar industries as well. So let's take to give the framework. Typical cement plant would say produce 1 million ton per year of cement or clinker. And 1 million ton is sold about $100 per ton. So we are talking about 100 million sales for a cement plant, roughly speaking, of course. And a plant to operate would need between 20 and 30 megawatt of installed power load. If you compare that, if this plant were to run purely on hydrogen, as example, a green hydrogen, it would require about 140 megawatt thermal of hydrogen just as a fuel, which means 200 megawatt of installed electrolyzer, which would be $200 million or $150 million, depending on what you consider for capex only. So this is to give you just a few large numbers so that it puts things in perspective.
So I imagine that most of the boards of these kind of companies or the senior leadership, the moment they really get a sense of those numbers, the question is how on earth are we going to achieve this? So we talked a little bit about the kind of scale of investment. We will talk in more detail about the models, but just give us an overview. Like when you're talking to clients about this, what questions come up and what is it, what are the types of structures that you talk about?
Well, I approach it with a financial structure that they might be used to, considering their experience, for example, with electricity supply, which can be done for certain plants using PPA, power purchase agreement, when the plant, for example, is in direct connection with a renewable supplier, a renewable electricity supplier, be it PV or wind. Those projects are usually developed as a special purpose company or special purpose vehicle, SPV, and require a stream of cash flow for the investor, and that comes in the form of power purchase agreement for electricity.
So that's the kind of the route into many of these discussions is finding that point of something that they're familiar with and then applying it to the different types of technology that they may then be considering.
Yes, it's not just them being familiar. I think it's the entire industry being familiar with this model. It has been also applied in certain instances with the alternative fuels. You may hear a lot in cement and other industries that instead of fossil fuels as a way to decarbonate, they would use biomass or waste. It's also a way to reduce cost, as those fuels or alternative fuels tend to be cheaper. But they are becoming to be scarcer and becoming more expensive. There are other outlets for those, and therefore they have to use lower and lower grade of alternative fuels, biomass or waste, which means in turn higher and higher preparation, meaning drying and grinding. So you end up with almost a full plant just to prepare these alternative fuels with larger investment. And those plants can also be developed as separate company.
So we talked a little about the scale of investment needed, but tell me a bit about who is actually financing these kinds of CO2 improvements at the moment. What are you seeing in terms of the proportion of investment and funding that can and is coming from the manufacturers versus investors or government? What's that landscape looking like to you? And then we'll talk more about the models.
Well, the landscape is still in the making, that there is no doubt of it. And so this is really the key questions. We have seen lately, let's say the past year, several large announcements for large projects around electrolyzers or CO2 capture or around this energy transition for the industry. But those announcements are really only for engineering study, FEED meaning front-end engineering development. So even if they're supposed to be for a complete capture of CO2 in a cement plant, for example, right now what's going on is a couple of $1 million investment in engineering. And this investment is mostly done these days by, in the US, the DOE, Department of Energy, and in Europe by various European funding schemes. The supplier, the technology supplier, really only provides their know-how. For most of them, they are more interested right now or needed to find investors than spend money that they don't have. And the plants themselves, they really mostly supply their plants and a little bit of their time and engineering, but not much money.
Let's have a look then at the kind of different finance and project models that might well work for the types of projects we're talking about. So we're going to have a look at 4 different examples. The waste-derived fuels, we're going to have a look at examples from energy storage, ways of financing the electrolyzers, and also looking at CO2 capture and offtake models. But if I start you back at the top of that list, so refuse-derived fuels, talk to us about what kind of examples of finance already exist in that space that could well be applied, moving forward.
Yes, so energy cost is the biggest expense for a cement plant. So there is a strong focus on alternative fuels, meaning waste or biomass, mostly to reduce the cost of the energy, thermal, but also these alternative fuels can be considered CO2 neutral, so there is a second benefit as well. These waste and biomass are becoming more expensive to get and more difficult to get as they have other outlets. That means what's on the market is lower and lower grade alternative fuels, and they require more preparation, meaning they need to be ground finer or they need to be drier and drier so that they can burn properly. So you are getting larger and larger fuel preparation plants to the point where it's almost a separate business, meaning that it's those plants are becoming independent from the cement plants, and they have to be treated as a separate investment, mostly under project finance. These are special company developers that are going to pool together financing from banks or institutional investors to develop first the project and then execute the project. And what's most important in those project finance under this special purpose company is that they have a stream of revenues. The cement plants will buy the fuels on the ton per hour or ton basis under certain specific conditions of quality, mostly calorific value and size of the product.
Of the models we're looking at, this is the one that I imagine these are already fairly well known. As a model, I mean, project finance is something that I think many of these companies are already engaged with on some level. What sort of range of size of project or types of project would that structure lend itself to? Because obviously there are going to be other ways of looking at finance things. So where does this fit? What types of projects is this most applicable to?
Well, that would be probably project above 10 million euro or dollar. The other projects are usually corporate financing. One has to understand that the cement industry, for instance, is investing two ways on its own money. Not only its own money, but it's buying competitors, or it's expanding into upstream and downstream markets, construction, building materials for one part. And it's also on a yearly basis investing in better process equipment and maintenance of the plants. The rest, those alternative fuel, those electricity, and now hydrogen, oxygen, and CO2 will have to be project financing.
Let's move into the kind of the secondary examples that we were going to look at. So what are you seeing, or what are we seeing around energy storage projects and how they are being put together? And again, how might this be applied in other industrial settings?
Yes, energy storage is the outcome of the penetration of renewable electricity. Renewable electricity, mostly PV and wind, is by nature intermittent. So for solar PV, it's going to only to be produced during the day. So that means to feed 24 hours a plant like a cement plant, you would need energy storage, or you need also the grid. So those projects are following the basis of sector coupling, meaning that the electrical grid and its client, the cement plant, would have to work in synergies to optimize the overall project. So from the grid side, that means providing electricity 24 hours a day, so meaning some energy storage. But from the industrial plant, that means maybe being more flexible, operating, for example, without grinding mills, which are the biggest electricity users, during the day only. So that by both sides being more flexible, project will be more efficient.
I know there are also the projects emerging, or the ideas for projects emerging with different types of energy storage, which are quite interesting as well for industrial settings. For example, in storing renewables as heat, or storing renewables in different ways, in addition to a battery or something like that. So there's a number of different examples we can pull from that kind of field of expertise.
Yes, and that's why we are getting closer to the hydrogen and the CO2, is that we are talking about technology that are still in the making or in the development. We have the well-known lithium-ion batteries, but they are usually for 2 to 4 hours duration storage. The development over the past few years has been toward flow battery, so-called longer duration storage, 6, 8, 10 hours. But most of this technology is still under development, even if there have been some demonstration projects. The same with other type of energy storage. Thermal, gravity could be going into this 6 to 16 hours needed to complement the renewable intermittency, but they are still not fully proven. And therefore, it's more difficult for those special purpose financing to take place because of the uncertainty and the bankability of the technology.
That leads us neatly then, doesn't it, into looking at the examples of how we finance electrolyzer projects, the hydrogen projects that people are, I think particularly in Europe, there's a lot of excitement around the possibilities from blue and green hydrogen. So talk to us about that. You know, what are you seeing in that space? What what does it mean to kind of construct a project that is investable in that space?
Yes, so the electrolyzers are not necessarily linked to cement or steel or lime industries. The green hydrogen can be used two ways for those plants. One would be in the energy storage. The other could be the hydrogen and oxygen, as it is both are produced from electrolyzers, to be used as fuels, either directly, I mean oxygen not a fuel, but as a boosting in oxygen enrichment or oxycombustions, hydrogen directly as a fuel, or after being methanized, meaning the CO2 and hydrogen through the Sabatier reaction producing CH4 or methane. So these are two ways where electrolyzer can be linked to energy intensive industries. So they are a good example of participating into the CO2 reduction business and also as standalone projects.
When we talked about this ahead of the podcast, you made this interesting point that may not be news to the listeners, but it just wasn't something I'd thought about, which was the idea of one way of financing things like this would be to replicate PPAs with an HPA, a hydrogen purchase agreement or something similar. But talk us through the different ways and means that could work for financing this type of model.
Yes, in the hydrogen sector, what we need, of course, is the outlet for the hydrogen. The good things with hydrogen is that there is an existing hydrogen market, so-called grey hydrogen. So there is a natural way for blue or green hydrogen. Let's talk about green hydrogen because it's linked to electrolyzer, is the displacement of grey hydrogen market, plus slowly new market on its own for zero emission vehicle, for methanation, for hydrogen blending with natural gas. So there is an established market which makes it easier for financing. The other positive things is that electrolyzers are not new. Unlike flow batteries or other form of energy storage, electrolyzers have been in operation for 100 years for the alkaline technology and for dozens of years for the PEM technology. I think the point is that the model is more or less going to be the same. What we have to see is where we are in what can make this model work, which works for electricity, works for alternative fuels, should work for electrolyzers because we have a market, so hydrogen can be sold. We have a technology that is not so old. And I was coming to the fact that we have also players that are mature. So we have seen over the past few years that the electrolyzer OEMs, which started as startup company or older, smaller private company, most of them have been bought. If you want, I can list them. Nel brought Proton on site, Cummins brought Hydrogenic, Chart Industries invested in McPhee, Mitsubishi bought Hydrogen Pro, Linde invested in ITM, MAN bought H-Tech of Germany, Plug Power bought Giner Helix, and Sunfire bought IHT. So that leaves only very few independent pure electrolyzer suppliers, which means those have higher valuations, have better balance sheets, and investors are going to feel more comfortable providing project finance.
Okay, useful. Thank you for that. The fourth model that we were going to take was CCUS, so CO2 capture and offtake. Yeah, what's your view here, whether it's point source or the kind of mega projects that we're starting to see in Europe or direct air capture? What is the ultimate business model here that cement or other sectors can use, and how are they going to finance that?
Well, we have to look at it two ways. There is a trend toward trying to produce the end product of aviation fuel, kerosene. That seems to be what makes the headlines, and everybody wants to go from direct air capture, and after many transformations, produce kerosene, and voila, we have solved the world problem, and the investors are very happy because it looks very good. I don't think it's a smart way to look at it, because those transformations in efficiency result in projects that are probably not making much sense. I much rather focus on shorter transformation project. Let's say a cement plant which will increase the CO2 concentration in the flue gas, and this flue gas being used directly for CO2 accelerated carbonation or mineralization, or even to grow microalgae. These are shorter transformation, and I think the better way to go.
Is there a market for the offtake of those things? Is it calcified CO2 or the algae that you've mentioned? Is there a market that's already in place for that?
Well, that's the big difficulties for the CO2. The market is very limited. There is, of course, some CO2 being sold to greenhouses, some CO2 for carbonation of drinks, but it has to be high quality, high purity CO2. The only real CO2 market right now is CO2 used for EOR, enhanced oil recovery, which is only limited to certain part of the Western Canada and Western US in reality. Otherwise, the CO2 market is artificial. CO2 sequestration has no value for the CO2 itself or for the carbon. So it's still in the making. And therefore, that's why the difficulty of financing such CO2 CCUS or CCU project.
A lot of the kind of the earlier stage applications for CO2 are interesting, but again, early stage. So I suppose it's still part of this question, isn't it? Is how do you build the business case for CO2 capture when there are lots of possibilities, but not necessarily the ready-made market?
Well, in all those parameters that needs to be aligned for project finance, they all have to be refined and improved. As you said, technology readiness for CO2 capture is behind electrolyzers or behind alternative fuel or renewable electricity. So that will have to be improved. It is being developed through demonstration projects that have been announced. And there are many startups, but there are some companies that have already been able to raise substantial amount of money and seems to be on their way to become active players. There is need to be development in the infrastructure that will come from mostly government or public-private partnership, CO2 pipeline being one example of that. Then there is the need to develop the CO2 market. There is a true market for CO2 through methanation, so CO2 transformation to recover the carbon as carbon black. That's another development that needs to take place. And then, of course, the CO2 valuation or CO2 tax or CO2 tax credit, as it is done in the US through the 45Q. That seems to be going to be an effective way.
So we've sort of gone through those four existing models that could be developed and made more sophisticated, for what is needed. Let's sort of change our lens a little to the other types of industrial challenges that lie ahead. I know, again, when we were talking in preparation for this, you raised a point that, again, I'm afraid me and the team at Decarb Connect probably hadn't been that aware of. But, whilst we know that any part of a kind of forward CO2 abatement plan obviously takes into account whether there's an implication for the quality of product produced or something like that, it hadn't really been part of our discussions or part of our thinking that it has to fit with the overall tech stack or the way that the overall process technology of a plant operates. So talk to us a bit about that. It's obviously not entirely simple just to bolt on some new technology. So talk to us about about that issue and what are industrials looking at doing.
Yes, this is the tendency within this energy transition world to oversimplify things. The general public thinks that just because it's green, it's easy. If you have battery and PV on your roof, you plug it and voila, you are autonomous. The investors might see things to be simpler than it is. And in the government, of course, and the politicians makes announcement for what's going to be 30 years from now. Very easy for them to do, since none of them will be in business 30 years from now. So, for example, I take for a cement plant and the CO2 capture. You cannot just take the flue gas and extract the CO2 and expect this to be going on smoothly for 20 years for the life duration of the plant. The flue gas needs to be relatively clean. Impurities or pollutants such as NOx, dust, SOx, mercury, even oxygen could be a pollutant for certain CO2 technology, or humidity. So that will have to be taken into consideration. If, for example, on NOx, you have to install a catalyst system, which is a known technology, to reduce the NOx to the level compatible with the CO2 capture technology, you are going to add several millions to your investment and make the operation of the cement plant even more complex. So that has to be taken into consideration in choosing technology or in developing projects.
What are the other challenges that are maybe not as obvious to people from the outside of these sectors? What else are industrials concerned with? We've talked about elements of financing, but what else do you think is on their list of worries?
Well, there is, for example, the CapEx. We have seen that it's going to be significant, but we are also looking at OpEx. A lot of announcements that are being made tend to only look at the core technology of the CO2 capture, but they are not talking much about the type of energy, either electric or thermal, that is going to be required. If it's cryogenics, you are going to have a lot of electric consumptions with the compressors. If it's amine, you need a lot of thermal steam to wash the amine and recover the CO2. And those are very significant, especially in relationship to the thermal and electrical usage of a plant. So we are talking about a factor of 2 to 5 to 10 compared to what they are used to.
You also talked to me about the idea of the difference in return on investment in terms of time that some of these bigger projects are also going to demand or require. Why is that a concern?
Well, as I said, these cement companies or lime companies, when they invest in process improvement or maintenance replacement, they are really looking at projects to have a payback of 2 years and less. It can vary, of course, depending on the company and the type of project, but usually that's going to be a limit. If we are talking about project just for waste heat recovery, for example, the cement plant has a lot of flue gas that temperature around 350 to 400 degrees C, that could be used to produce electricity. But in most of the developing world, those projects are going to be 5 to 8 years return on investment. And so they would need some different type of financing or different type of incentive to be set in place.
I know you made the point again in our prep chat about the need for a different lens on how you hedge against these sorts of projects because of various risks that perhaps are not in the normal scope of things on a kind of 2 to 3 year investment cycle, or 2 to 3 year investment return style project. So what sorts of additional risks are there that really kind of need to be hedged against when the financial model is being built?
Most of those parameters in this project are unknown. The electricity price is not certain. The price of natural gas, although for example, in the US, people expect it to remain low, but we have seen that it can spike. The cost price or tax credit on CO2 is also very unknown. So all these are the key parameters for the valuation of a project. I'm not talking about bankability of the technology and other things. So this is what makes those projects difficult to finance. And that's why we are going to have to look at the world of green bonds, the work of reinsurance. The major industrial investors are probably not going to be the plants themselves, pulp and paper, lime, cement, or glass, but there seems to going to be the major oil and gas companies, especially the European one, like Total and BP, that have announced they really want to be active and investors in the transitions, as well as the utilities, because they have the means and the structure to be the major actors.
A last question from me is, we've talked a lot about the risks. We've talked about ways that people are going to need to think about this. I mean, probably still one of the most common questions that we hear from people is about, well, when are we going to see a market for low carbon products or zero carbon products, or somewhere in that space? What's your view on that? I know again that you're kind of mostly focused in the cement sector, but are you seeing movement? Are you seeing a kind of an opening up of the market for those products?
Yes, it's being announced. Green steel, green cement, green lime, green paper. They have been announced. They are being sold still at a relatively small quantity. So the market has to grow, and there should be incentives, maybe price contract for difference in certain markets, where there would be subsidies to offset the difference between a green product and a gray product. The government might put regulations where for their project, they will require cement to have a certain low CO2 content to be used in governmental projects. The general public will also have to realize that at least initially they may have to pay more and be willing to pay more, but we have seen that it might be the case for all the bio products that people are now buying. Initially there was a larger price difference. That difference seems to be lower and lower. So things have to get started, I think, and that will have to come from all the different stakeholders in the economy.
Okay, well, Xavier, thank you so much for giving us your perspective. That was really useful. It's kind of unusual to meet someone who has that lens both on Europe and the US. Often people are very focused in one or other region. So thanks for bringing that to the discussion as well.
Well, you are very welcome. I had been privileged to be able to work on both sides of the Atlantic, so I enjoyed that. Thank you.
Great. Thank you very much.